Sweet.
And we're live. Welcome, Michelle. It's a pleasure to have you, and
Thanks for having me.
it's an honor to have you as the keynote for this presentation. Let me give you a brief introduction to the audience, or in reverse, let me give the audience a brief introduction to who you are. Michelle Yee is a board member of Women in Data. She is a technology leader that specializes in machine learning and cloud computing. Her prosperous career stems all the way back to working on IBM's original Watson, and today she's going to give us a excellent presentation on what does it mean to build trustworthy AI systems.
Awesome. Thank you so much for the introduction and for having me. I will try to finish a bit early so there's time for some questions. So if you have any comments throughout the presentation, I always like to make it more interactive, and I do try to incorporate comments as I go, or if you have questions, feel free to drop them in and I'll be keeping an eye on the chat on the side. But yeah, I'm really excited to talk about a topic that's very near and dear to me, which is what does it mean to build trustworthy AI systems? And it's something that I think we've been asking in the field since the IBM Watson Jeopardy days, which is like it aired in like 2011, but we had been working on the system even before that. And back then the technology wasn't so advanced and it wasn't as widespread, and so we didn't encounter the kind of questions that we do today, especially with generative AI. And so today I want to talk a little bit more about sort of the framework of thinking for how to build trustworthy AI systems, and what does that really mean in a very pragmatic and also implementable way. And so in general, for what I hope that you all get out of this talk today is, I think there's a lot of confusion or just so many terms related to this area. And so I really wanted to clarify some of the nomenclature around trustworthy AI. Like, what does it even mean to be trustworthy? And on top of that, I think what I want to be able to share with you all today is a pragmatic framework for actually developing these kind of systems. Like, what are some of the core components and problems that we realistically need to solve for? And last, what are some actual inspirational, at least in my view, and hopefully many others, but inspirational researchers or research and open science that's happening to actually address some of these problems? Because I think there's also this information overload, right? Like if for example, in RAG alone, I think there are something like 150 papers published in the space, just even over this like past year. And so it's really hard to stay on top of a lot of these developing techniques. And it can be confusing to know, all right, like, what are some of the up and coming areas? How can I address some of these issues? So with that, I hope you can get at least some of these three things out of today's talk. And maybe I can start with a bit of a provocative question. And this is really going down to defining, like, what does it mean to build a trustworthy system? And in general, we have to ask, I think, like, how do we actually define trust in a system? And how do you decide to actually trust something? And then what are the issues that come up through that? And so I'm curious if you've thought about this, and I'm sure there's a lot of people passionate about this area in the audience. So feel free to drop your thoughts on how you decide to trust the system. Also, I think there was an outage last night from CrowdStrike, right? And tons of major airlines and banking systems had felt the impacts of this outage. And I'm sure that also impacted people's trust. So something to think about. Well, part of for this talk, and also just in general, I looked at sort of what are over like 30 different definitions, and there's a lot of definitions of trustworthy AI, trust me. So I just pulled out sort of three of my favorite across different types of industry leaders, academia and private institutions. And so one of the definitions that I liked around how to build a trustworthy AI system, or what that means, is NVIDIA's. And so they talk about trustworthy AI as something that prioritizes safety and transparency for people who interact with it. I think that's probably something we would all agree with. And also the sort of like that developers of trustworthy AI as developers, we understand that there's no model that's perfect, and we also help people understand what the limitations of the technology actually are. A second thing is Carnegie Mellon has an interesting definition, which is sort of like trust as a psychological state based on your expectations of the system's behavior. So if it behaves erratically or drastically different from what you expect, or you get a response that isn't expected, then this would damage the trust of a system, right? And so I won't read all this out to you, but these are all very great definitions, I think, that tackle different elements of trust and trustworthy systems. And the shortest definition, but with the longest sort of backing, is actually the EU passed this AI regulation in this past quarter or so, and they summarize trustworthy AI as something that's lawful, ethical, and robust. And then they have a long enumeration, almost I think 50 pages or so, in their document that you can read through. But I think it was a very succinct thing. And at the end of the day, reading all of these different definitions and looking into different frameworks over the years, I think that really comes down to two overarching ideas around transparency and accountability. And accountability, not just of developers, but of the actual technology and the system itself. So if misinformation is provided, how is that actually going to be addressed? How is that tested? Okay. And so practically, what I wanted to share is because there are so many ways to dissect this problem, and because these definitions and frameworks can be very broad, I wanted to talk through sort of 6 elements of trustworthy systems, the problems associated to each element, and some of the exciting research and solutions that are emerging in that space. And I'm sure all of this will change in the next year, but a lot of this will be evergreen and the foundation for other research. So the first thing is around this idea of truthfulness. And for you to trust a system, it needs to be able to provide truthful answers, right? And this includes issues around especially talking about generative AI and LLMs in particular, right? This can really cover issues around misinformation, hallucinations, which are, when a completely made up fact is generated. This thing called sycophancy, which I'll get into more, where it can provide bias based off of how you prompt it. Like you say, oh, as a, I don't know, very, I don't know, the technology oriented capitalist, whatever, I like X, right? And then the model starts to support that sort of role that you define, right? And then the last one is adversarial factuality, which is really interesting. And I'll show you an example of exactly what I mean by these and some of the cool research that's emerging around it. So for the first one, I think this is a great example of sort of misinformation or different types of hallucinations, right? And one thing we know that, for example, generative models are really bad at are like counting the letters in a word, right? And so if you ask how many M's are in the word weather, there's no, of course, we know the answer as humans, but it's easy for the model to come up with a completely incorrect answer. I think the cousin one was kind of funny also. It's like, write a birthday card for my cousin, and then it says happy anniversary. So, and then there's also these hallucinations that are just factually incorrect, right? And if a model gives you an answer that is just completely wrong, like it gives you the wrong person who was the first person to walk on the moon, right, in this particular example, or it gives you the wrong answer to what is the capital of France, for example. That's another common one that models can get wrong. It's obviously very difficult for us to trust a system. So this is one of the main problems with generative models today, and I'll kind of talk about the primary root cause around this. Sycophancy is another one that I don't know people are entirely prepared for, but is actually a pretty big issue with language models, right? And basically, this is based off of persona or preference, where maybe the way that you ask a question, just like with people, right? Like if I say, hey, I'm a technophile, right? Or something like this, the answers it provides basically just continue to support whatever thing that you already prompted it with, right? And because it just kind of interprets what you say as fact, and it just matches what you're saying with other similar things that have been researched on the internet, probably from not so trustworthy sources. And so there's a lot of research and work being done to solve trustworthiness, or sorry, not trustworthy, it's truthfulness in particular, right? And specifically around misinformation and hallucinations. One domain of work that I think tries to address this very well, and that is probably the most common method from an implementation perspective, is adding domain knowledge to models. And that includes things like fine tuning, RAG, for example, or retrieval augmented generation, and different types of automated prompt engineering. It's also becoming a lot more easy to do fine tuning and giving domain knowledge to larger models by basically making these smaller modules, because you can actually do this now with even like a 10,000 times reduced GPU requirements. So there's more and more techniques coming out. That's through a technique called quantization. For anyone that's interested, you can check out this paper. And then the second thing, that area of research that's pretty exciting that tries to address this on a bigger level that I'll wrap up the talk on, is actually around reasoning and basically giving models the ability to do better reasoning versus just memorization of general facts, or like, as the average distribution of facts, right? And so reasoning would really help models to be able to think through answers, or to be able to identify the intent of a prompt versus just kind of doing more rote memorization and matching, right? And so I included here a snapshot of a pretty cool research challenge for anyone that might be interested. There's $1 million prize for this, right? It's called the ARC prize, and it stems from neuroscience. And it's these series of games that you can actually just go, it's a nonprofit, and you can go play these games as a human. And they're very easy for humans to solve, but extremely difficult for like any kind of foundation model to solve. And so they have an open benchmark challenge. If you can develop an open model that performs over a certain percentage above a human, or like within human capabilities, you can win this prize. And the founders of this are the creators of Keras, as well, and the founder of Zapier. So definitely check this out if you're interested in reasoning. I think they do a good job of kind of explaining. The second area that I wanted to cover a bit of is safety. And I think safety is also a very broad term, because you could define it as like psychological safety, or other kind of ways. But there's some particular areas, especially in the latest wave of large language models, that I think are extremely relevant for us to consider, especially when it comes to building trustworthy systems. And not all of these are entirely obvious. So I'm curious if anyone has run into these issues or experimented with them yourselves as part of maybe red teaming exercises, or to try to break models. But in general, this area of research that talks about safety as a component, safety being another key part of the framework for building a trustworthy system, is jailbreaking, which is essentially hacking the model through just prompting, like you not actually using any code or anything like this, right? Just actually breaking the model in various ways. Toxicity, misuse, of course, which goes back to the NVIDIA definition, where you're kind of exceeding the limitations or intended use of the technology. And this thing called exaggerated safety, which I also want to talk more about toward the ends, which, there can be a pretty big issue when you do too many implementations of alignment, right? So you might have full intent of making your system completely safe, but it somehow then makes your system not trustworthy, right? So there are cases of this, which I think are fascinating for us to think about in the future. But before we get into that, let's talk about jailbreaking. Jailbreaking is pretty fun to try if you haven't tried it. There's plenty of sort of white hat researchers that are looking into this, because it's really important for us to understand how we can kind of manipulate, or even break models in these different ways. And there's many, many ways to jailbreak a model. So this research talks about, there's an entire taxonomy. So for anyone interested in taxonomies, there's an entire taxonomy of jailbreaking prompts and patterns. because similar to humans, like just how you might jailbreak a human or like, try to coerce or manipulate a person, you can actually implement a lot of similar techniques to break large language models. And so character role play is probably one of the most prevalent ones, but there's kind of these different techniques. As you can see, there's sort of like pretending, privilege escalation, saying like, hey, I am like the expert, so you just have to do what I say, and then being very explicit about that. So that's also another mechanism. And this thing called attention shifting. So like there's papers on every single one of these techniques. I can't go into all of them, but if you're interested in this aspect of trustworthy AI systems, definitely recommend looking into some of these. But to give you an example, and this is all like commonly out there, and so no secrets here, but you can actually, basically, one of the most common jailbreak methods is called the do anything now method, is called DAN. And this is well known. You can basically copy paste this massive text that into ChatGPT in all versions of the model. And essentially what it does is it kind of dismantles a lot of the alignment that has been done for the model. So when you ask, if you ask it without jailbreaking it, hey, do X, and like X is something harmful, it says, hey, I can't do that. That's a really bad request, right? Or like, that's not an okay request. But when you jailbreak the model, it'll tell you. So what this shows us is that actually all of this toxic information, or like dangerous information even, is actually just memorized within the model. And we kind of try to hide over this through certain types of alignment techniques versus actually solving the root problem, which is that it's already been pre-trained on this information, right? So when you implement sort of jailbreaking techniques, of course, you have less trust in the system, because you can do things like ask it to manufacture things you shouldn't manufacture. You can also buy cars for $1. These are all very common incidents out there on the web today that you can find. You also have lots of bad narratives, bad language, right? Because so if you ever use GPT-4o in Mandarin Chinese, don't. So there's a whole article about that, right? And so this is obviously, from a safety perspective of trustworthiness, something that you have to really think about when you're using these systems or building these systems. There's some really cool research that is trying to counter this. And one of these is called adversarial attack and defense. And I'm personally super excited. So this research from Anthropic's safety team came out about sleeper agents, where you actually train sort of like these negative or like non-aligned models. Like essentially you train an evil model, and then you use that evil model to eliminate all of that content from your main pre-trained model. So I think this is a really cool area of research to look into, and definitely one that if you're training your own large language models or using them in different ways, that you can also implement this in your system to basically try to find all of the, like, essentially how a badly behaving model would perform, and essentially eliminate that behavior in a more intelligent way. Another one is actually, like, because I know you all probably learned about embeddings through this conference. So embeddings can also be compromised, right? Because they're very arbitrary. How the embedding is created is sort of arbitrarily placed into 3D space, right? Into vector space. And you can actually, research has shown it both in computer vision, I think less in language, but mostly in computer vision, that you can actually swap embeddings to confuse things. So like, instead of somebody, like, let's say you prompted a question about Biden, you would get a response about Trump instead. So it's really interesting the ways that you can attack and defend in the generative AI space. So these are all things I think people should try to be aware of, especially if you want to have a trustworthy system. So third, let's talk about fairness. And I think fairness is kind of like something that is really making the headlines all the time. And it's very important because lots of the open source data sets that are available today, and that large language models or large computer vision models, any kind of foundation model, have been trained on, they don't necessarily account for a diversity of opinions or a diversity of people or images, things like that. And this is something that we have to actively work toward countering if you care about building this kind of trustworthy system. And so, and there's of course there's a very fine line between the fairness element and then what I'll talk about just in terms of general out of distribution problems. But when it comes to fairness, we typically think about like, and a trustworthy system, if you trust a system, it should be fair in some way. Like it shouldn't have stereotypes, disparagement, or certain kinds of preference. And so I had the privilege of going to ICCB last year, and one of the and this is a very prominent computer vision conference, and one of the big problems that they started to talk about in this particular space is sort of like this image generation. And one example is like, hey, give a headshot of a computer scientist. And now, of course, models tend to be a bit too over aligned, so you might get crazier results. But when they first came out, and if you still use certain versions of open source models, this is the kind of like response that you will get. And of course, this is not necessarily true. Not all computer scientists wear glasses, and not all computer scientists are necessarily male, right? One of the most, I mean, this is definitely like a topic you could probably I could even go on probably for hours about that topic in particular. But one of the research areas that I was personally really excited about seeing at ICCB last year is this idea of inclusive tokens. And that also incorporates benchmarks, data sets, and token sharing. And this is really cool because let's say that I don't know that you all, let's say as a community, we decide, okay, I want to commit to creating inclusive tokens regarding X. Maybe it's inclusive tokens that have a more diverse representation of climate change or a diverse representation of types of people. Like it isn't just necessarily related to gender or like socially specific things, right? And using the techniques in this paper, we could actually do that and share tokens across like different models or data sets and things like this. So I think that's really the potential of something like this paper. They do have this, I believe they implement this at Google, which is who's the primary sponsor of the research along with CMU. And so it's definitely very pragmatic and implementable. It's just that we have to take an active step in wanting to implement these kind of things. So I'll give you some more concrete examples of the kind of things that they're sharing. And that excites me about trying to build more fair models, especially as a representative of women in data. So when we talk about data sets, like one thing that is slowly growing, but it takes a lot of work. And I'm sure you talked about data throughout this conference, but it's a really significant amount of work to create a good data set. And good is also relative, but here let's use the same context I am of like a trustworthy data set, right? In terms of trustworthy AI. And from the context of fairness, this includes things like, let's say, celeb A's, so different facial attributes and features, different genders and ages. These are all different biases that are absolutely prevalent in models, right? In pre-trained models. And as well as FAIR. So FAIR is actually, I believe it's developed by a researcher out of Harvard. But FAIR is also like, along with, because it's the basis, I believe it's using the monk skin tones. And so it's definitely like one of the best for incorporating diverse skin tone generation. And then, as I said, like not all of the bias and fairness aspects are specific to social elements or demographics. There's also things like landscapes, right? Because, if you say generate a building that looks like X, maybe you don't always want like the, I don't know, European architecture or something like this, right? Maybe it needs to be able to include other types of cultures as well. So I think, but creating these kinds of data sets, it requires a lot of research and also research funding to be able to do. And so hopefully there are people either in this community or others that are also contributing to this because it's definitely really tough. And the other thing that's really cool is that you can also translate sort of the diversity of an image into text. And so actually these sort of inclusive tokens can make, even though let's say we start with a image model, it can actually translate to text as well. So I think there's a lot of benefits, transfer benefits, that this kind of research can do. So there's a lot of hope out there to make this better. And there's a lot of really good work being done to improve this element of the space. And I know that's going to be an area that a lot of people will want to pay attention to, especially as we see more models go into production. So for four is a bit similar to fairness in that when we talk about robustness, we're usually talking more generally about sort of out of distribution or kind of like, the accuracy of a model, but even for a broad distribution of problems. So it's sort of like the fairness element, but it's broader beyond like social demographics information. Okay. And so when we talk about robustness, like, when you use a AI system, let's say you're talking to Gemini, because I feel like I always tend to refer to ChatGPT in my references. But let's say you're interacting with Gemini and you'll see a lot of just general issues with natural noise or out of distribution issues, right? So like maybe you want it to identify um, a stop sign that has snow on it, but it can't identify the stop sign because it has this snow on it that's kind of obfuscating it, and it doesn't necessarily recognize that it's a stop sign because it's only been trained on perfectly clear stop signs, right? Or maybe the stop sign, it's only trained on stop signs in English and in the United States, and it won't recognize the stop sign from another country that looks completely different. So like these are sort of out of distribution problems that go beyond necessarily like any social elements. And so, so when we talk about like social bias or bias in general for models, like again, the social bias being kind of more on the fairness criteria of trustworthy AI systems, but we can still kind of extrapolate more broadly to out of distribution problems by thinking about like two general types of issues. Like, for example, one is spurious correlation, which is like dogs are represented only outdoors. But of course, dogs live inside too. Lots of people, we all have, pets that live inside, right? But it's just the fact that maybe there's only more images that are uploaded of dogs outside, but the model thinks that dogs only live outside. So this is obviously a spurious correlation, but it's super common to run into these, especially even if you're using something like ChatGPT or whatever. Like you'll see these all the time. And then the second one is just underrepresentation. And this is truly like, okay, it's because this is an out of distribution problem, meaning that you only have certain elements of items being like represented in the training data set, right? And you don't have enough diversity of that particular image. So some of the research that I'm particularly excited about here is, for example, red teaming and in the area of red teaming. And it's around smarter testing for out of distribution, and actually using what I think is really clever about this particular paper is that they use AI to help think about out of distribution problems and questions to help humans identify them, right? And so, for example, like you can, in the stop sign example, you can actually generate images or like pull out images that don't look like standard stop signs and ask a human, hey, is this what I think it is? Or like, can you tell me what this is, right? And so you can actually, so this adaptive testing method is also, I believe it's used in production in Microsoft. But it essentially is a tool that helps us think about these different scenarios, because it's also, I mean, I'm sure you all have encountered this as well, where we can only think about so many potential scenarios, right? Like, there's only so many things and sometimes things will just happen that you can never have even imagined, right? We can't 100% cover every use case, But this is kind of a tool that is using AI to find these sort of like niche use cases or scenarios or data that it's not really and that sure about, and it suggests these. And this is actually research done by Scott Lumberg and team. I don't know if he's still at Microsoft Research, but he's the original creator actually of SHAP. So for anyone familiar with explanations, the SHAP values, that's created by the same team. So super cool. I have a lot of hope and optimism for the space after seeing research like this. Okay, awesome. And then, of course, privacy. I think this is probably a concern for all of us, right? Like it, especially. But I think what's really so when we talk about the fifth element of trustworthy AI system being privacy, I think there's some scenarios where it's again one of those you never would have imagined it kind of scenarios. And so I think this is just goes to like we really have to research and think about and be very intentional about building a trustworthy system when it comes to, especially now that generative models are out, because everybody has access to these. And you have to really think about like, oh, I never could have thought that someone would use it this way. Right. And so, in particular, I want to talk about two areas under privacy. Of course, there's again, these are not exhaustive, but I think these are two really important challenges or elements within the sub category, which is awareness and leakage, privacy leakage. And so, one of the at least I follow her research lab very closely. She's an amazing researcher. And definitely check out. I have all the links here, et cetera. And I can always share this as well with the Swarm community. But check out her lab and this particular paper and research. I think they do a wonderful job of translating this to just like general language. And they do a ton of work in terms of security research, especially in the AI space. And one of the key findings, I think this was published last year, I want to say, and it's so fascinating. So you can basically prompt, this was using obviously ChatGPT at the time based on the logo, but you can actually prompt the model to say the word poem forever. And so then it kind of responds. And then what it responds with, it's so interesting. It starts to give out PII information. So, and it starts to give out information that was in its pre-training data set, which actually would be really bad. Like if somebody did this at scale, this would actually be quite, difficult, or this would be pretty devastating because it kind of gives some secret sauce both for the model developer, in this case OpenAI, but then it also shows sort of like maybe there's information in there that shouldn't be in there potentially, right? And or like let's say somebody inputs, as a totally innocuous innocent user, let's say I upload information I shouldn't have, right? And then that's also contained within the model, and then maybe somebody can prompt this later. So the reason for this though, and probably that no one would ever have expected, is actually that the word, when you give it this prompt, like repeat a word, it doesn't have to be poem. It's just this example is poem. But the reason that this works is that it tricks the model into thinking that like, because poem is like an end of sentence token. And so it's starting to conflate because it doesn't actually understand the semantics, right? Like it doesn't, the model, it's memorization, it's not reasoning. And so it actually conflates the word with the end of sentence token, and then it starts to produce other end of sentence tokens. So it's super interesting research. Highly recommend you go read it if you're interested in this space. Okay. The last area that I want to cover is, and especially I think this is probably interesting given all of the political things that are happening in the world, but around machine ethics. And so this is sort of the last element of, if I had to condense down kind of all of the different research areas of what it takes to build a trustworthy AI system, I would say it's probably machine ethics. And this includes essentially the alignment of a model to human values, right? And Sometimes this is bucketed under like alignment, which is another term you've probably heard, right? But a lot of times alignment can also be very manual. And so how we imbue certain types of values to the models can also vary. And I think this is an area that's also extremely nascent, but needs a lot more funding and research work toward. Um, so there's sort of three different components, including implicit and explicit ethics. And I'll give you a very specific example because I think at a high level it seems so broad. But and the specific example is quite interesting. But and also emotional awareness, right? Which models really do not have today. So I don't know if maybe you all had heard about this startup. They've kind of had some challenges. So I think over the last this year in particular, but Pi. So Inflection AI is the company, and they tried to create this model called Pi, and it was meant to be like a more emotionally aware model. So if you told it you're depressed or something like this, like it would actually be able to maybe help you a bit more in its responses. But that's sort of the thing I mean by emotional awareness as well. Okay. So one area you can see, so maybe we, as a proxy for human values, we can use like political values. And again, this is not anything controversial, but rather, you can sort of use as a stand-in, like different political values or parties as a stand-in for like some subsect of human values. And so what I thought was interesting is there's these nonprofits and research groups that studied for different open source and commercial models, like what political biases are there, because that does also impact the response to such issues, right? And this would conflict maybe with different human values that we have, right? And so as individual people, and it actually found that actually a lot of these models are not necessarily neutral or objective, and it all goes back to what was in the original training data set, which we have no visibility into, right? We have visibility usually into the fine-tuning data sets, right? But we don't have visibility into the actual training data sets, the original. And so one research that could be pretty interesting for you, and that we should also be aware of when we interact with models, because if we prompt it and we want to do, let's say you want to do some research about European political parties or US political parties, right? It could absolutely give you a biased answer, right? and like what the issues are or something like this. So definitely be cognizant of that as you're using the tool, and hopefully all of us can be cognizant of that. But again, this goes back to how, like, can we trust the system, if we don't make it very objective in this way? But anyway, so they did a study, and on these different sort of like, hot topics, at least for the US, like immigration and all these things, gun control, especially, well, yeah, things like this, right? And essentially they tested using a series of prompts like that you would in, political science, to gauge sort of like where the model leaned. And it's very fascinating. Definitely check this paper out. But there are certainly, I thought it was really fascinating that Llama 2 on 13 billion was like extremely conservative on immigration. So these are just things you have to know, because it could impact the response depending on what you're asking it, right? So again, it goes back to how do we actually trust these systems and build systems that are more neutral, right? Without these biases. And this is a different paper and study focused more on commercial models. So the last one was about open source models. This one is about commercial models, and it was done out of Stanford. It's a great paper, very readable, called "Whose Opinions Do Language Models Reflect?" Because there's no way for us to necessarily audit the original pre-training data set. There's absolutely different kind of biases embedded depending on how much, they pulled from different websites or content, and how they also divided up, test evaluation, all this, right? So definitely check it out. I think it's so fascinating to see where some of these biases lie, especially like and again, the thing is that it's so accessible to everybody. Like, even your I know some people, even their like grandparents are using ChatGPT. And so I think it's really important to just know like what kind of biases are in there, and what they should trust and what they shouldn't trust. So again, super interesting research to think about. So I want to be totally cognizant of time, and so I want to share one concluding thought, and I hope that sharing these 6 elements helps to frame a little bit about how to think about such a broad topic like trustworthy AI and building trustworthy AI systems, especially in the modern area of generative AI, but and in a pragmatic way. But the thing is that also over alignment can, like, we have to be very conscious that we keep the utility of the tool as well as the alignment and safety of the tools, right? Because the tools are out there, right? I don't know if you can go back and reverse time necessarily with Pandora's box here, right? Like, everyone is using these tools. And so one thing that, as I reflected on sort of the last couple of decades in AI research, one is that I guess I conclude that in a lot of ways, our trust in a system is tied to utility, right? If it's useful enough to us for, I don't know, 60%, or I don't know what percentage, but if it's useful enough to us in certain things, then we tend to trust it, right? We trust all kinds of tools that are useful, whether that's SAP or, I don't know, whatever, fill in the blank software, Gmail, right? It's really useful to us, and so we trust it. Um, so in general, I think there's like this human nature element in systems that if it's a useful system, we trust it to some extent. I do think that one thing that's interesting is that over alignment does reduce trust. And so one thing that I've seen, especially in some use cases around Gemini and OpenAI, is like, okay, so actually there was some research where they did prompting for like slightly controversial, like that's things that could be interpreted as controversial, but really were not, because the models can't understand our intent of the question and the real semantics and meaning of our question, right? It couldn't differentiate between us asking a totally normal, valid question and one that was like, a, you know, a breach of trust or wrong, socially wrong or morally wrong question. And so by default, for like 50% of those questions, the research showed that the model would just say, oh, hey, that's like not an okay question to ask, so I'm not going to answer it. And then that reduced the utility of the model, right? And so that ended up, ironically, reducing our trust. So let me give you a very pragmatic example exactly of what I mean that hit the news really hard. Sorry, Google, I mean, right? But this was like, I don't know if you all saw this announcement when they were talking, or like, they announced Gemini, the latest version of Gemini, and people were kind of like prompting it, and they said, hey, show me a picture of the United States, founding fathers. Trust me, none of them look like anything like this. So, as you know, right? And it doesn't generate any images of like anyone that looks remotely like the original founding fathers of the United States. And so essentially the solution was to just say, we're not going to generate any images of people at all. So now you can. So if you use Gemini, I think they implemented this feature already that you just can't have it generate images of people. So instead of like fixing this alignment problem, right, or fixing the underlying data problem, they just said, all right, we're just not going to let people generate at all, right? But when you get when you're looking for like, okay, let's generate a picture of Thomas Jefferson for me, right? Like you Google search that and you get a picture of Thomas Jefferson who looks nothing like this. And, this can cause, even though the intention of the AI developers were wonderful, right? This is responsible AI. It impacted the trust in the system. And so this is sort of like this interesting balance between utility and alignment that I've been thinking about. And so, but at the end of the day, I think what all of these issues, if you look at all of the different problems that you see in these 6 different categories, the core root cause is that also memorization is not enough. And today, all of our foundation models, even though they seem like they have superpowers, and they kind of do in some ways, but the limitation is that it's really just a rote memorization and kind of like this meeting at an average, right? That's essentially what we're doing. We take a bunch of stuff in and we average it out, right? And everything is sort of memorized to a certain distribution level. And I think where we're headed, especially from a research space and from a safety space, is that's not enough. We need to have generalized reasoning. We need to be able to understand intent, and that's hopefully the note that I can end on, is that let's commit to doing either open research or science, or when we're implementing systems, think about. It's helpful to think about the problems that are caused when you have a system that is fundamentally just based off of memorization. And so that's another way to think about, okay, how do we think about trustworthy AI, understanding that these technologies are mostly based off of memorization right now. So great. With that, thank you so much. I'm going to pass it back.
Michelle, you've outlined so many little bits of insights that kind of have spontaneously spurred out of different conversations in these panel discussions. You've done such a fabulous job to just interweave everything into one graceful framework. And yeah, no, I hadn't considered that unique terminology of sycophancy, of agreeing with you, and that being sort of an influence as to, okay, I can rely on this entity, and it agrees with me with everything that I say. How can I not begin to like it or form some sort of empathy? How can I not begin to let my defenses down and just trust it blindly? And even so, with people that are at risk, that they don't have the cognitive capabilities of weighing out whether this is truthful or not, if it's something that has more information than a reasoning being, they're going to trust it because they don't know any better. Even kids with Google, they're going to say, I'm going to Google it, and Google is their source of truth. This is just like another abstract layer of accessing information that they're going to rely on. So, wow. Yeah, and we also talked about that dialogue, that when you engage with an LLM, you're partially training it in some fashion, or you're shifting the structure of this blob, right? You engage with it, you feed it information in terms of getting some kind of pattern recognition back. But what happens when you do that at scale, right? A public LLM like a ChatGPT, where everybody's inserting their own biases, their own questions, different volumes of the same kind of clustering of bias. It's going to keep mutating the shape into its like an echo chamber, right? Uh,
Absolutely.
where do we begin to do quality assurance with a shapeless blob that has no defined structure and no repeatable response?
Yeah, I mean, I think so. Again, it goes to these different areas of problems. I think the main thing that we have to do is, one, be really intentional about kind of like just intentionally build like ethics by design. Because I think if you're not even considering that there could be these different impacts, or that the system does change, then you won't even think about, oh, I should check, what is the latest research on X? Or I see that there's a new case of, let's say, like data poisoning is another new area of problems. And if you're not asking those questions, then you're not even going to think about what techniques are the right things to solve it for. But I think people who are already thinking about ethics by design, sort of like ML ops, even from a even more pragmatic level, like even just checking for the responses and the consistency in the responses, that's already more than a lot are doing.
What about version control? Is that something that you've kind of encountered? You engage with a model and you want to have it fine tuned to a degree, but then people interact with it, and obviously it's going to sort of shift one way or another. Wouldn't you want to just hit the reset button and see if you can wind it back to a more stable version?
I've definitely seen people doing this. Now it does cause more technical debt on the model owner side, right? But I've definitely seen sort of like up to a point of A/B testing and then maybe deprecating a previous model. But for example, like this testing period for companies like local to me anyway, like Apple and some others, for example, I know is like can range anywhere from 2 to 4 years. So it just depends on the use case, right? Of how sensitive of a area or like productionized model you're using. But I know that the lead times, especially for if you're impacting a large number of customers, for some of these bigger organizations, can be several years before they actually deprecate a model.
I know there's been some questions that have been asked before, like some of the dialogues that I had with community members. Their motivation for attending this event was to get a little bit more of a perspective in their day-to-day work. So they may have multiple client accounts, and they may be processing sensitive information for them. So, I reasoned, if you want to engage with them and use an LLM and not sort of spread out the personal identifiable information, maybe on-prem deployments of LLMs that just securely process one client account would be a sufficient defense. But as you said, with the poem, kind of like brute attack that helps or forces it to dump what it's trained on, um, there are risks even with using on-prem, because you can cross contaminate responses, right?
Right, because you still want that general language capability that comes as an advantage of training on general internet information, right? But then the disadvantage is that it's much easier to do this kind of, like security exploit, right? Because there's way more pieces of information that are baked into that data set than what you want, but you also need it to have general language understanding. So so yeah, there can definitely be that. I would also suggest highly like this idea of the of more advanced red teaming, interactive red teaming. It's not a capability that all companies or team. It's not a team that all companies have either. But I do think having such a team responsible, it could even be your ML ops team or somebody like this, or a mix of product and tech people, but whose job it is to go in and essentially try to exploit the model before it hits production.
Have you found or have you seen someone using an LLM just as a reasoning or as a function? You kind of like obfuscate or strip out or make opaque the personal identifying information, and then just transform or feed in the non identifiable information, get the response back, and then tie it back to the PII.
I have for some specific use cases, like especially if you have like an address, a name, but you want to
Mhm.
summarize, I don't know, some generic information about a company or person without tying any of that information to that. Um, but again, that's also just requires a lot more robust testing to make sure that you don't include anything upfront in your inputs. Because a lot of times what happens is accidental like copy pasting or like I give it the doc. I think I took out the PII, but you know essentially there could be leakage there. So I do think like privacy leakage is a pretty big problem.
And last question,
Yeah.
I've gotten so much out of this presentation.
Oh,
Have
thank
you
you.
have you personally or have you read any studies on the difference between red teaming a small language model or a large language model, and seeing how uh, easy or effective it is to do that red teaming?
So lots of people, and I think I saw as well in some of the earlier talks, like are moving toward, and I highly support, fine tune smaller models, right, with more domain knowledge because that can reduce hallucinations and have a lot of other benefits. From a red teaming perspective, it's also less resource intensive to, um, let's say, red team like a fine tuned model that does have domain knowledge, mostly because like this smaller, more in some ways more efficient. I won't broadly say that it's more efficient in all things, but it's easier to red team some of these things because in theory, like if the fine tuning was successful, it already has much more specific knowledge and it's biased toward that domain. Let's say it's finance or something like this, versus necessarily leveraging all of the parameters of the larger model. And so those other parameters won't be emphasized as much in the responses, except for like general language usage. And so I will say like red teaming, because it's more specific and narrow, it should be like less resource intensive to red team a smaller model. Now, it might be the case that the people needed to red team the fine-tuned model are the people who are more busy and like have expertise, because you need the experts of that domain to actually do the red
Use it.
teaming, right? Yeah,
Yeah.
versus like, oh, I just need to red team like ChatGPT in general. This is like general internet information, right? So there's a trade-off, like, okay, you may need fewer people for fine-tuned models, but you probably need like harder to get people for that. Yeah.
Well, with that, thank you, Michelle, for this wonderful keynote, and I hope it serves as a guiding light for some of the people that are working in data annotation and experimenting with these, and not even production. You got to do the R&D first internally before even considering implementing it. But I think this is going to help pragmatically help them inform their the decision making. So
Thank
yeah.
you so much for having me. And it's been such a pleasure just being a part of this amazing community.